The 777 was the first Boeing aircraft to incorporate the fly-by-wire system. A well-designed automatic flight control system that improves performance and safety, combined with pilots having the ultimate authority in all situations of the flight, has made the aircraft one of the best to fly. In our 777 flight control series, we will understand how the control surfaces function. Let's start with the horizontal stabilizer. The horizontal stabilizer is used to trim the pitch of the aircraft, and behaves differently in flight, in comparison to ground operation. To best understand its architecture, let's operate them on the ground, and the flight operations will be covered in the subsequent elevator chapter. At the heart of the aircraft flight control system are the three primary flight computers. All control surface commands, whether from the pilots or the autopilot computers, has to go through the PFCs. To help the PFCs there are four converters, called the actuator control electronics. Multiple computers offer redundancy and accuracy. Let's keep one computer of each system, for simplification. The stabilizer trim switches are on the control columns. The switch in the up position gives aircraft nose-down signal, and in the opposite direction gives a nose-up signal. The switch electrical signal goes to the actuator control electronics. The ACE converts the analog signal into digital, and sends it to the PFC. In flight, the PFC takes several factors into consideration, before calculating the speed of stabilizer movement. But since the aircraft is on ground, the PFC allows the stabilizer to move at maximum speed. The final calculated signal is sent back to the ACE. The ACE now converts the digital signal to analog, and sends it to the two stabilizer trim control modules. The trim modules control the hydraulic power to the stabilizer actuator with the help of solenoid valves. Of the three hydraulic system in the aircraft, one trim module uses the center system, and the other uses the right system. The signal from the ACE opens the nose-up solenoid valve of the module, and hydraulic pressure is now sent to release the brakes on the ball screw actuator assembly. Simultaneously, hydraulic pressure from the modules runs the two hydraulic motors. The motors, with the help of differential gears, turns the ball screw to which the stabilizer is connected. The leading edge of the stabilizer moves down, to give aircraft nose-up attitude. Stabilizer position indication is given in the cockpit, with the help of position transducers. Once the stab trim switch is released, the trim module is directed to stop the stabilizer movement. The module stops the hydraulic motors, and re-engages the hydraulic brakes. The brakes prevent inadvertent movement of the stabilizer when not commanded. The aircraft also has an alternate pitch trim lever for manual control. The lever, through mechanical cables, is connected to the manual valves on the trim modules. Let's move the lever for a nose-down command. Cable movement causes the control rods to move the manual valve cranks. The trim modules now releases their respective brakes and runs the hydraulic motors. The direction of motor rotation depends on the direction of crank movement. As the stabilizer moves to the nose-down trim, releasing the trim lever causes it to return to the neutral position. This closes the manual valves, and the trim modules executes the stop procedure. Join us in the next chapter of the flight control series, as we continue to dive deeper into the pitch control system of the aircraft. Thanks for watching.